Hey everybody, we're continuing with 3.5, and this is another time-honored technique of integration, and that is using tables of integrals. Now you could have this is a very short table. It's just two different integrals. But let's look at this. The integral of 1 over x squared minus a squared is equal to 1. By the way, there should be a dx there, but they just didn't write it. 1 over 2a times the ln of x minus a over x plus a plus c. Now, how they got that, that's a different story. That's something we're not going to go into. Some of these are not that hard to actually figure out. Some of these are very hard to figure out, but right now we're just going to take advantage of the answers. So I may give you a problem with this. The integral of 5 over x squared minus 9. So obviously it looks like this top integral, but it's not exactly like it. Like this has a 5 instead of a 1, and so forth. So we just have to identify, well, first of all, we have to figure out what is the a here. And that's not so hard because 9 is just, this is very annoying. This is annoying that 9 is just 3 squared, which means that my a is going to be 3. So now we're just going to put a 3 every time I see an a over here. And what am I going to do at the 5? Well, I could just pull it out of the integral. You're allowed to pull a constant out of the integral. So it's just going to be the same result as what I have here, but it'll be 5 times that. So now I'm just going to go use a equals 3, and I get 5 times. Now originally it was 1 over 2a. Now it's going to be 1 over 2 times 3, and the ln of x minus 3 over x plus 3. And just to simplify that a tiny bit, 2 times 3 is 6, so it's 5/6 the ln of x minus 3 over x plus 3 plus c. So I used the table. So the table didn't give me the exact final answer, but it gave me very close to it, and I just had to tweak it a little bit. Okay, now let's look at another example. Okay, so x squared over the square root of x to the 6 plus 16. Well, let's look at our table. Let's go back up that table. So it's similar, but not exactly the same. So what are we going to do here? That is always the question. What are we going to do? So what we're going to have to do is we're going to have to sort of massage and manipulate what we have here to make this more similar to the, oh, look at that, to make this more similar to the actual integral on the table. So here's what we're going to do. Let's go through it step by step. So we're going to do a little trick. X to the 6th power is the same thing as x to the 3rd power squared. So I'm going to write it that way. And if you notice, the derivative of x to the 3rd power is 3x squared. So my x squared dx, well, look, it says right here, I'm going to let x to the 3rd equal u. So I'm going to do a little u substitution. And du is 3x squared dx. And I have an x squared dx in the integral. I just have to deal with the 3. No big deal. Just, that's just equal to 1/3 du. And then the next thing I'm going to do is going to make that substitution. So u is going to be, so x cubed is going to be u. I'm going to stick it right in there. The x squared dx is really 1/3 du, so it's du over 3. And now this is equal to 1/3 the integral of 1 over u squared plus 16 du. And this now looks exactly like the table, like what we had on the table. Let me just remind you again. This is like exactly what we had there. We had 1 over the square root of x squared plus a squared. So now we just got to figure out what is the a, and that's pretty simple. We're going to see the a is going to be 4 because I noticed it was a 16 there. Let's just go back to it. There we go. There we are. And now we just have to figure out what is the a, and obviously a is 4. So our answer is now going to be 1/3 times the ln of u plus the square root of u squared plus 16 plus c. And now I just have to back substitute. I like it, this is undoing the substitution. I have to back substitute just because we can't give it. there was no u in the original problem. We can't just give a u, that no one's gonna know what u is. So we have to just back substitute. U is x cubed. So now, and this here, this here is that there. It was just manipulated. It was manipulated to look different, but it's the same actual integral. So now this becomes 1/3 the ln of x cubed plus x to the u squared is now x to the sixth plus 16. In all is that all of that's in absolute values and plus c. So it's all good. And that's a very time-honored method of solving uh, uh, integrals, is that you use integral tables, but like I say, it's not always going to be straightforward. Sometimes you have to manipulate or massage or just play the algebra just to get what you're given to look like the integral on the table. Well, that was it. It's pretty quick and pretty fun, and we will. Whoa, I'm trying to say what's going on here. Why am I not? Oh, here we go. And see you guys next time. Bye.